okay, will be horizontally constant. V against T 0 ma. So it will be horizontally constant as well, but at the 0 line, x-axis side. For negative velocity, it will be linear but terbalik, okay, from high to low. For the V against T, it will be 0. Okay, at 0 V. Okay, this is 0 V, sorry, at the downstairs, going down. Constant negative velocity. Okay, can Then for uniform velocity, all these terbalik, this one, the graph, terbalik, this one also. Now from negative, it goes above the 0. However, uniform velocity indicates 0 acceleration. So your acceleration T graph, you have a what you call horizontal line at 0. All right, jot this down as well. Done, okay, next let's continue. Then uniform acceleration. So uniform acceleration means that the increasing ratio, the increasing rate of velocity, I mean the velocity is getting higher and higher. You see, sorry, the increasing rate is constant. Okay, see, so but why the distance keep on increasing? Because velocity increase ratio is constant means that it keep on increasing. So keep on increasing means that it's getting faster and faster and faster. So your displacement should getting higher and higher and higher. The increasing rate will be getting higher and higher, but the velocity will be straight. Why? Because it's uniform. So for acceleration, it's a straight line as well because this is uniform acceleration. Uniform deceleration, terbalik. You will be going fast until getting slower, slower, slower until you get stopped. So that's why your velocity is terbalik. And this one also terbalik is under 0. Okay? All right, got this down. Okay. All right. So we try to do some questions. Okay. See these. Okay. Try to do these two questions. Yeah. All done, huh? All right, so let's see the answer. So now, the first one, okay, he wants you to calculate the velocity of OP, QR, and RS. So OP, this is S, so we use 20 minus 0 divided by 2 minus 0. So which is 10 meter per second. For QR is 0 minus 20 divided by 7 minus 5. So which is negative 20 over 2, which is negative 10. Then for this one, RS, we use negative 10 minus 0 divided by 8 minus 7. So also negative 10 meter per second. Okay, for total displacement, you see 20 plus 0 minus 20, negative plus negative 20 plus negative 10. So the answer shall be negative 10 meter. So what means negative 10? So it means that it moved to the opposite direction from 10 meter away from the origin. Okay, original line, original point. Okay. All right, next. For this one, the same way, calculate the acceleration of OA and BC. This is velocity versus time. So we can use the final velocity minus initial velocity divided by time. Like this one, 10 minus 0 divided by 10 minus 0, which is 1 meter per second square. BC is 0 minus 10 divided by 25 minus 0, minus 20, sorry. So it's 10 minus negative 10 over 5, which is negative 2 meter per second square. Now, for the total displacement, so total displacement, we can include this as a, you see, this as a, we have a, how many? We can make this a trapezium, correct? This is a, we try to make this a trapezium. Okay, so we use 1 over 2, 25 plus 10. Here, 20 minus 10, 10. Okay, 25 plus 10. Okay, multiply by 10. So your answer is 175 meter. Okay, or you can use like area under the graph. Okay, you add 1, 2, and 3 together. Also can. Okay, you do it correctly. Okay, all right. So let's see the conclusion. So the gradient of the graph S against T is velocity. Gradient of the graph V versus T, okay, is acceleration. Area under the graph V against T is displacement travel. Okay, so check this out. Make this a star. This is an important one. Done, huh? All right. So let's see 2.3, free fall. So we said an object is free fall when it fall under the gravitational field strength only. So free fall means that we fall down only with the due to the gravitation. Let's say if you throw something down, is it free fall? No. You throw something, actually you give a pushing force from your hand. You drop something, drop. Yes. So remember, the questions might play around with you with this kind of words. When you say an object has been dropped down, so it's under free fall. Okay. So a piece of paper does not fall freely. Why? Because its fall was affected by air resistance. So free fall only, we can only say it's free fall when it's only in vacuum. Because normal time, the thinner the object, the wider it is, the slower it will fall down. Like with a piece of tissue, when you same tissue, you try to make it into a something round, you drop down, and just a cupping one will just let it fall down. Of course, the one with the wider one fall down slower because we have air resistance. But free fall does not include air resistance. It only we can say it's free fall until vacuum, and in vacuum. Okay, so the absence of air means that no air resistance to resist the motion of the object. So in vacuum, both light and heavy object fall freely. Okay, so they fall with the gravitational acceleration. So the acceleration is due to the gravity, which is G. Now we know that formula of force is F equals to ma, right? If the force due to gravitational gravity is mg, like for example, F equals to ma, but if object falls under gravity, so F will be equal to mg, where g is gravitational acceleration. Okay, you understand? Can I? So this is what he's trying to tell you. So under free fall, when you drop down a feather and a 1 kilo, how do you call 1 kilo heavy object at the same time on the same spot, it should be touched down together. It should touch down together under free fall. Under free fall, okay. You see the feather normally, you see it slow down, right? Slow down is because of the air resistance. So without air, they should drop down at the same time. Should be but under vacuum. Okay, so jot this down. This is important, because your Form 5, quite a lot of the calculation are actually based on this one. Because Form 5, we are talking about perfect condition. Perfect condition means that no resistance. Okay, Nana. All right, so let's continue. Now, for example, okay, I know. Let you guys try the questions first. Try this one. This one you might need to jot down the questions, okay, because this is for you to do the what you call it, revision later. Done. All done. Okay, so let's see the answer. Now, okay, hold a golf ball and a piece of paper at the same time, same height, sorry, and drop them simultaneously. Okay, now the first one, okay, so which one will reach the floor first? The golf ball under normal condition. So why? Because it has a larger surface area, so the air resistance acting on it is greater. Okay. Now we repeat with a golf ball and a piece of paper which is crumpled like this. So both reach the floor at the same time because both have same size and surface area. So the mass does not affect the gravitational acceleration. Okay. So in short, the factor that affect the free fall only surface area. Mass does not affect free fall. So like for example, under our gravity, when you hold like normal with air, when we free fall a ping pong ball and an iron ball, same size, same shape, both will hit the ground on same time. Okay? Can I? All right, so jot this down, jot the answer now. Yes.
The first question number 2, I put the answer. The paper does not fall freely because the presence of air means there is no air. There is air resistance to resist the motion of the object.
But you didn't mention the okay. You if 2 marks, you get 1 mark because you didn't mention the main idea why cause air resistance. So the surface area you have to jot down because that is the reason why air resistance increased. Okay. Done. Okay, so let's continue. Okay. Now the difference between free fall in atmosphere and free fall in vacuum of a coin and a feather. So you see, according to the what I call that, coin and feather are released from the same height simultaneously in the laboratory. So you can see that the coin falls faster than the feather. Why? Because a bigger air resistance act on the feather because it has a large surface area. The gravitational force on the coin is able to overcome the air resistor better than the feather. Okay, because this one have resistance, this one lower. So the gravitational force on acting on this is actually after you cut off the resistance is higher. Okay, this is why it said overcome air resistance. Okay, understand that? So the same coin and feather put into the vacuum tube and drop simultaneously. This is the second one. You will find out that both reach the bottom of the cylinder at the same time. Because in vacuum, there's no air resistance. So the only force that acts on the object is gravity. And both objects free fall with acceleration due to gravity, despite of their mass and shape. Okay, because the only thing that acting on the feather and ball now is only gravity, and gravity is a constant value, 9.81 meter per second square. Correct. So that's why they will hit the ground or fall on the ground at the same time. Can I understand? All right. So let's see when we try to explain the acceleration that due to gravity. So acceleration due to gravity is the acceleration of an object due to the pull of gravitational field strength. The gravitational field strength comes from the core of our Earth. Okay, so the standard value is 9.81 meter per second square. Sometimes we just put it in 10 for simplicity. Now, if your questions didn't mention G always equals to 9.81, unless it mentioned that it's 10. If no, you have to use 9.81. Unlike your Form 1 to Form 3, Form 1 to Form 3, use 10 if they didn't mention. Okay, so the magnitude of the acceleration due to gravity is depends on the gravitational field strength. So in short, the stronger the gravitational field strength, the higher the G. So let's say when you are going away and away from the surface of Earth, your G increase or decrease? Decrease, because the effect of field strength is lower now. Okay, because it's like magnet, when you're going further and further away, the attraction will be lesser and lesser. Okay, so this is why in moon, you will find out that moon we only have, I think, I forget, I think 1/6 or 1/3 of the gravity value only. Okay, what is this? Okay, all right, just jot this down. Done, huh? Okay, huh? So let's see an example on this. So the diagram on the right, okay, shows a stroboscopic photograph of a free falling ball and a graph of velocity v against time t. So he wants you to observe the photograph and describe the velocity of the ball, which is, you see, is getting the distance is getting bigger and bigger. Okay, you see, stroboscope is like a photograph, but he's like snapping maybe 1 second 5 times, and then it combine it together. Okay, it's like your, what you call that, your frame per second. Normally it comes out with frame per second. Now, so because the snap of the time, each gap, the gap of each snapshot is the same. So we can consider this motion from here to here, the time taken is the same. From here to here is the same. From here to here is the same. Correct? Because it's taking frame by frame. So you see the distance is getting bigger and bigger. When time is the same, this the velocity, I mean the displacement getting higher and higher means that the velocity is increasing uniformly. So what can you deduce from the gradient of this graph? The gradient is the acceleration of the ball. So deduce means that what can you conclude from that particular thing? Normally, it's asking you what is that? What is the gradient of the graph? So it's the acceleration of the ball. So describe the motion. So the ball move with uniform acceleration because the increasing velocity is by uniformly. Can I? Now next. Anyway, is it? Hold two stones of different size at the same height, and then drop both stones simultaneously from the same height. So he wants you to describe how the velocity change. So when we hold different size at same height and then we drop it, so the velocity will increase uniformly because keep on acting with the gravity. So the time taken for the stones to reach the floor will be the same because mass does not affect the acceleration. Okay, free fall only affected by the surface area. Okay. All right. Jot this down. Okay, done. Done. Okay, so let us continue. Now let's see for the acceleration due to gravity. So okay, the aim here is to determine the acceleration due to gravity. So they need a ticker timer. You need a ticker timer. Okay, the AC power supply. Stool is this one. Sorry, this one, the small chair. And then G clamp, slotted weights, and also the ticker tape. So we cut a piece of ticker tape about 2.5 meter long and pass through the ticker timer, which is clamped to a stool, okay, using the G clamp. Then we attach one end of the tape to the 100-gram slotted weight. Then we switch on the ticker timer and release the slotted weight so that it falls freely. Then we analyze the tape. So now let's see. Okay. Make this your title, okay, for the experiment and draw this. Okay. Like I said, no need to draw like too detailed. This is only for you to understand. Okay, done. Done. Let me know. Okay. All right. So next, let's see. So why is difficult to describe the motion of falling object by just observe the free fall? Okay, because the object move very fast. That's why you can't use your eye visual to check it. So what is the type of motion of an object falling under the pull of gravity? We call the motion will be uniform acceleration. So why is that the motion of slotted weight can be assumed as to be a free fall? This is the assumption. Normally, if they ask the assumption, so why we use the slotted weight as a free fall? Because small air resistance is negligible. Anything when we fall not under vacuum will experience air resistance. No matter how small it is, it will experience air resistance. So the only thing that affect our calculation is air resistance, but it's very small. So normally we just neglect it. Okay, what step did you take to minimize the friction between the ticker tape and the ticker tape timer? So hold the ticker tape vertically when releasing. Make sure it slips through the ticker tape smoothly. Okay. So it means that we hold it up when we try to release the ticker tape, because somehow when you free fall, it will actually drag the ticker timer as well. So normally you try to hold it up. So that's why I think your school, if asked you to do the experiment, maybe 2 people. But nowadays, I think your teacher doesn't do experiment at all. They just ask you to like, they just show you maybe, I don't know how nowadays. And explain the need for the slotted weight to be dropped from a high position. So why we need to get higher position? Because the calculation will be more accurate. Why? Because when you go to high position, means that the distance, the free fall distance will increase. Free fall distance increase means that we can have more segment to calculate the free fall. You understand? Because when it's too short, like for example, from here to here, so very short. Somehow when you release, pop, you already finished. Maybe 2 dot only or 3 dot. So the longer it is, the more dot you will go. More dot you will go, you will able to check the which one is the real uniform acceleration. You understand? Huh? Can I? Okay, now. So how we calculate the G from the tape? So first we try to get the U, try to get the V, then we use A equals to V minus U over T. Okay, so normally let us compare the value of acceleration due to gravity with the actual value. So normally the value from experiment will be lower or higher. It should be lower because you have air resistance. Air resistance, no matter how small it is, it will still affect your readings result because it is there. It is there. Okay. So compare the value of when we change 200 gram to 300 gram, it should be the same for the result because free fall mass does not affect it. Okay. So why? Because mass does not affect the gravitational acceleration. Okay. So the important formula, like we said, we already have this one, right? So it's still using back this one. Okay. So the only thing that you have to remember is in free fall, A equals to G. Acceleration equals to gravitational acceleration, which is 9.81. Okay. Now, and then when at the highest level, okay, like for example, when the object we throw upward, you see, when the object we throw upward, the A will be negative. Why? Because you see, this one is thrown upward. All right. But our G is moving down, so opposite direction. So that's why it's negative 10. We don't use 10 normally 9.81. Okay. So at highest point, it goes up first until it gets 0. Stop. Why it go highest? Because that thing stop and then free fall. So that's why at the highest point, V equals to 0. So when downward direction, under downward direction, your V is positive. When upward direction, your V is negative. Why? When we throw upward, the motion will affected by gravity, which is on different direction. So your velocity will go in, slow down, slow until it stop. All right. So this upward direction, your V will get negative because the value is getting smaller and smaller. However, when it throw down from 0, it will be affected by gravity and going faster and faster until it reach gravitational full force. Okay, so it's positive. You understand? How we determine the value? Can I? All right, so I'll try to jot this down. But change, this one we already had, you don't need to copy this. Because they just, you see, they just change the A into G only. Okay, so you just change, jot down the note and this. Okay, but change 10 into 9.81. Okay, done. Huh? All right, so let's see the next one. Oh, exercise already. Okay. There are, I think, 4 questions. Okay, try to do these questions.